So now that we've introduced these derivative shortcuts, rules if you will, we're going to talk about how to use those rules to differentiate both polynomials and things similar to polynomials. Now, polynomials are simply powers of x that have been added or subtracted and could potentially have constant multiples in the form of coefficients. Everything that I just described, we have a rule for. So with that in mind, let's take a look at a couple of basic cases. I believe in a previous video, we talked about f of x is equal to x cubed minus 7x. I would like to differentiate this using the shortcuts that we now have in place. So f prime of x, this means I am about to differentiate x cubed minus 7x. According to the difference rule, that means that I can differentiate the x cubed and differentiate the 7x individually. Now we can apply the power rule to the x cubed, multiply by the current power, and reduce the power by 1. 7x would be considered a linear polynomial, and the derivative of a linear polynomial is simply going to be the slope. Now feel free to check back and see how long that derivative took in the other video in comparison to how long it took in this video. Now what if, by chance, a polynomial comes to us in its factored form, like 5x minus 3 times 2x plus 5. Unfortunately, it is not true that I can just differentiate each of these and then multiply them together. That's not the way that things work for products. What we can do instead is, before we start doing calculus, we can start doing a little bit of algebra and expand this. My second favorite four-letter F word is being used right now, and that is FOIL. I'm going to say this many times throughout the course of the semester, so you might as well prepare yourselves to hear it now. A little bit of algebra can save you a lot of calculus. In fact, if you take me for Calc 2, well, you'll probably hear that even more from me. So in its new form, we can apply the derivative shortcuts that we've introduced in our previous videos. So we are about to take the derivative of 10x squared plus 19x minus 15. First, we can apply our sum and difference rules. Sum and difference rules say that we can turn this into the derivative of 10x squared plus the derivative of 19x minus the derivative of 15. Next, applying the constant multiple rules, we can call this 10 times the derivative of x squared plus 19 times the derivative of x minus, well, the derivative of 15. That's just a derivative of a constant term. That's going to wind up being 0. So in the first instance, this would be 10 times 2x plus 19 times 1 minus 0. So that's the power rule, the identity function, and a constant term. Then, putting it back together, it reminds us of better times, 2019. Well, 20x plus 19, I suppose. Now, something that's definitely not a polynomial that we can still use algebra to help us out would be if I give you a rational expression, but the rational expression contains just a power of x in the denominator. Yeah, let's go big on this one. Let's call it x cubed. So as long as this is a monomial, polynomial with only one term, we can distribute this to all three of the terms in the numerator and refer to them using negative exponents. So 3x squared divided by x cubed minus 5x divided by x cubed plus 7 divided by x cubed. Anytime you're dividing powers of x, you are subtracting the exponents, so that'll be 3x to the negative 1 power minus 5x to the negative 2 power plus 7x to the negative 3 power. Now I realize that this is our first real go at this, but we're going to make use of the derivative shortcuts, and we're going to try to do it in one step instead of multiple steps. If this is too quick, leave me a comment and I will do my best to explain further. So essentially what's going to happen is we're going to use the sum and difference rules to break up the derivatives here. We're also going to use the constant multiple rules to pull the 3, the 5, and the 7 out of the derivatives. So we are going to get 3 times the derivative of x to the negative 1, minus 5 times the derivative of x to the minus 2, plus 7 times the derivative of x to the minus 3. Each of those is going to require the use of the power rule. For the power rule, we multiply by the current power and reduce the power by 1. Multiply by the current power, reduce the power by 1. Multiply by the current power, reduce the power by 1. After that, the only thing left to do is make a couple of cosmetic changes. Make sure that each term only has a single coefficient. If you're interested in turning this back into rational expressions, you're welcome to do so, but as far as I'm concerned, you are now looking at your final answer.